The height in meters above the ground of an object thrown in the air after t seconds follows this quadratic function that we're given. H of t equals negative 16t squared plus 112t plus 11. So three different things that we want to try to be able to find out here. So first, from what height was the object thrown? So we want to think about what about our function mathematically would tell us this kind of information. So we're looking for an initial value for height. So on this function, the input is time, and then the output is height. So we want to know when time equals 0, what is our height? So essentially we're evaluating our function at 0. So another way to think about what's happening here is it's really asking us to find the vertical intercept. The vertical intercept is what tells us that initial value for height. So to do that, we're going to evaluate. That means plug in h of 0. So everywhere there's a t, we're going to replace that with a 0. So negative 16 times 0 squared plus 112 times 0 plus 11 is just 11. So the vertical intercept is the point 0, 11. When time is 0, our height is 11, which means that it was thrown from a height of 11 meters. So an initial height is really the vertical intercept. We can find the vertical intercept of any function by evaluating h of 0, an input of 0. The second part says, what is the maximum height that the object reaches? So if you try to picture what the graph of this function would look like, it's a quadratic function, so it's a U-shaped graph, but our value of a is negative, which means it's an upside down parabola, so it opens facing downward. And so the maximum height is going to happen at the vertex of our function. So when it asks us to find the maximum height, it's really asking us to find the vertex. We have a formula for finding the vertex for a quadratic function that's in standard form like this. So our vertex formula says that we can find the input coordinate of our vertex by taking the opposite of b all over 2a. So in our equation, a is equal to negative 16, b is 112, and c is equal to 11. So the opposite of 112 all over 2 times negative 16. So negative 112 over negative 32 is 3.5. So that's the input part of our vertex. So that's representing a time. To find the height, we need to now take and plug that into our function. So h of 3.5. So negative 16 times 3.5 squared plus 112 times 3.5 plus 11. Let your calculator do the simplifying here for you. Is 207. So 3.5 is telling us a time. 207 is telling us a height. So it's telling us that this object that was thrown reaches a maximum height of 207 meters after 3.5 seconds. So think about, you started with an object that was 11 meters in the air. It was launched upward. After 3.5 seconds, it's up to a height of 207 meters, and then it starts falling back down to the ground. So that brings us to our last question then. When does the object hit the ground? So think about, if it hits the ground, then the height is now 0. The output is 0, and we're looking for the input. This is the same as asking us to find the horizontal intercept. So when the input was 0, it gave us the vertical intercept. When the output is 0, it gives us the horizontal intercept. The way that we find a horizontal intercept is that we need to solve our function set equal to 0. So negative 16t squared plus 112t plus 11 equal to 0. So notice that when we're doing a vertical intercept, we think about evaluate. When we're doing a horizontal intercept, we think about solve. That's true for every type of function. So here to solve this equation, we've got some large numbers. I'm going to go ahead and use our quadratic formula. So we already found a, b, and c in the last part, so now we're just going to plug those into our quadratic formula. So we need the opposite of b, negative 112, plus or minus the square root of 112 squared, minus 4 times a, which is negative 16, times c, which is 11, all over 2 times negative 16. Go ahead and let your calculator help you simplify this expression. So I'd encourage you to simplify inside of the radical first, and then put that whole expression into your calculator at once. We should come up with two values, one when we put in the plus and one we put in the minus. So try this on your own calculator. See if you can get negative 0.1 and 7.1. So it takes some practice to get used to putting an expression like that into your calculator. So here we're finding a time, so a negative value does not make sense as an answer here. So 7.1 is what we're interested in. So this is telling us that it hits the ground after 7.1 seconds. So you started at a height of 11 meters. You launched it into the air. It went up for 3.5 seconds until it got to a maximum height of 207 meters. Then it started falling back down to the ground and hit the ground after 7.1 seconds. So one function, but 3 different types of things we can do with it using key features of that function. So horizontal and vertical intercepts, as well as the vertex. Each of those key points on the graph helps us to answer one of these questions.